Hello everyone, and welcome to our session, Alexa Charge My Car, Test Drive the Accenture EV Roaming Platform. I'm Dean Phillips, Worldwide Tech Leader for Automotive at AWS. I'm based in Detroit and lead our Solution Architecture Technical Field Community. I'm excited to have with me today Rafael Menelashino, Managing Director of the Accenture Automotive Practice. We've been working together on this new solution to address the challenges faced by EV owners when it comes to finding and paying to charge their vehicles. This solution creates a better experience for owners by helping OEMs integrate the charging process into their mobile apps, as well as the HMI of the vehicles. Let's take a look at the agenda for our session today. First, I'll describe the e-mobility ecosystem and the value our new solution brings to the industry. Next, Rafael will describe in detail the architecture of the platform, all the way up from the mobile app, the in-vehicle interface, as well as the connected back end. And then he will finish with a short demo of the overall solution. Electric vehicles are forcing a convergence between industries. Automotives are rushing to develop new EV platforms and product lines, while at the same time struggling to transform themselves into mobility service providers, bringing information technology and traditional automotive, electrical, and mechanical engineering to places they've never been before. Entirely new in-vehicle software architectures are being developed to enable agile DevOps practices that allow vehicle software to be updated over the air with regular frequency. Since batteries are the most expensive components in the vehicle and must be continuously monitored with onboard tech and in cloud software solutions. Utilities are working to provide clean energy and implement standards alongside e-mobility service providers and automotive OEMs like the Open Smart Charging Protocol and the Open ChargePoint Protocol to enable seamless delivery of clean energy and charging experiences to customers. Combine this with incentives legislated by local, state, provincial, and federal governments to lower carbon emissions. We are in a race to put more EVs on the roads along with the charging infrastructure that provides electricity from renewable sources to address the challenges faced by climate change, with the ultimate goal of creating a zero-emission transportation system. On that point, sustainability has been, in fact, significant changes at Amazon. As part of our commitment to the climate pledge, Amazon ordered 100,000 new electric delivery vans from Rivian. This is the largest order ever of electric vans on the market so far. Amazon plans to start using those new vans to deliver packages to customers starting in 2021. Considering the complex ecosystem I just described, AWS and Accenture have collaborated to develop the EV Mobility Services Platform. Our goal is to create a portfolio of services to support electric vehicles and enable roaming across charge point operators with integrated payment and user experiences, including advanced navigation services for intelligent charging and trip planning, as well as charging station management for the utilities and charge point service providers. Digital personal assistants like Alexa make this even more effective for drivers to find charging stations on their way to destinations. Like what we showcased with Accenture at CES back in January, you want to be able to plan a trip and align recreational activities or food stops along your route that fit your preferences and previous buying patterns. Combining Alexa Automotive natural language interactions with artificial intelligence services like Amazon Personalize make this possible. Additionally, payment for services across a variety of charge point networks get aggregated in a single experience and payment wallet. Nobody wants to fumble around with multiple apps, remembering logins and updating payment methods. In addition, OEMs want the flexibility to integrate their existing connected vehicle solutions with multiple charge point providers without having to develop complex one-to-one integration that we abstract away with this solution. So what are the challenges we address in our solution? One of the biggest issues is the challenge of integrating all the various systems into the charging experience. For example, while vehicles are attached to charging stations, the details of the event are not shared from the charge point operators with the OEMs. Clearly, from the vehicle perspective, OEMs are gathering data on their side as it relates to the safe operation of the charging experience and its effect on the battery. But there is additional information from the charge point operator, like cost of electricity and perhaps source of electricity and details on how clean it is. This is exacerbated in Europe when charge points may be operated by various national utilities, thereby requiring EV owners to have multiple apps to charge their vehicles. Our solution provides a unified experience in a single application provided in the OEM companion app to find, reserve, and unlock charge points and pay for the electricity. Value-added services generate additional revenue opportunities, including data gathered from the ChargePoint network. And finally, we hide complexity and fragmentation by providing a service broker for simple one-to-many integrations for OEMs. So what outcomes does this provide? Overall, we help increase sales of EVs by reducing the friction of the EV ownership experience, making it more attractive for those who are overwhelmed or unsure about this new powertrain. Secondly, we reduce the CapEx by 40 to 50%, providing the integrations to mobility service providers, enabling seamless roaming between platforms for plug-in electric hybrids and battery electric vehicles. We create new revenue streams to compensate for the after-sales losses against traditional ICE vehicles through predictive maintenance services for battery lifecycle management, and create a distinctive end-to-end experience to differentiate OEM brands by delivering value-added services. So what does this look like? I'll give you a quick overview, but Raffaele will show you a detailed demo. First, you have the mobile app that came with your vehicle. Our solution plugs into this app. In here, you activate the service and can find all the charge points available on a single pane of glass versus managing multiple apps. Next, you have the in-vehicle experience on the HMI in the car. This system connects to our APIs to help you find and plan for charging events on your trip. Of course, this is all enabled by Alexa if you prefer voice interaction. Lastly, all the authentication and payment authorization is federated by our system into the various ChargePoint providers, so you don't have to deal with that complexity. So now that I've introduced the challenge and our solution, let me hand it over to Raffaele to dive into the technical details.
Thank you, Dean. Good morning, good afternoon, good evening, everyone. So my name is Raffaele, and in this part of the presentation, I will present the project that we have done together with the Amazon Web Service team for developing the electric vehicle mobility service platform. So let's get started with the functional architecture. So in this slide, we are showing what is the collection of functionalities that we want to develop in our platform. So first of all, who are the customers? The customers for this platform will be primarily car makers and mobility service providers that want to provide additional services, compelling services, value-added services to their electric vehicle users. In this respect, we have developed this platform, which is not meant to be just a collection of functionalities to be integrated into existing connected vehicle platform, but rather we want to develop a platform which is self-standing, scalable. We want to scale horizontally by adding new applications, new services as soon as they will become available. Should be scalable vertically. I mean, we have the ambition eventually to serve thousands, if not millions, of different vehicles. Should be open. As I said, we don't want to integrate these functionalities within existing connected vehicle platforms, but rather having the ability to interconnect with any existing connected vehicle platform or mobility service platform through standard APIs. And finally, it should be modular. So the intent is to develop different applications, different services that can be enabled or disabled to follow the expectation of our customers. We can integrate with any additional third parties, as you see in the bottom part of this slide, and particularly with those providers that can provide roaming services. Because as a matter of fact, one of the most important functionality that we want to provide with this platform is the capability for users, for the drivers, to use any possible charging point operators without having the headache of using different applications, different touch point. But all the users will use the same touch point, the mobile application or the in-car systems provided by their mobility service provider. For the purpose of the demonstration, for demonstrating the functionalities of this platform, we have also developed a small scale of a connected vehicle platform, because this is essential, right? Because this platform will be then integrated with connected vehicle platforms. And at the same time, we have developed two touch points, two user touch point. One is a mobile handset, which is the companion application that typically the mobility service provider provide to their customers. And the second one is the head unit, so the system that eventually is installed into the cars by the car makers. So you will see in the next slide, a description of all these different component and modules that we have developed with, of course, then a particular focus on the EV mobility service platform, which is the major reason for this project. Now, if we move to the next slide, this is the way we have developed the onboard system. So here we are into the car. Into the car, we have selected a standard commercial head unit. We are using a NVIDIA chipset. And on top of this, we have installed a Linux operating system. But more importantly, we have installed Greengrass from Amazon Web Service. Greengrass is a container where we can develop the necessary applications using standard languages. We have used primarily Java for this development. But the most important thing is that Greengrass keep a clear separation between the hardware and the applications. And therefore, the applications that we have developed could be, in principle, brought across any possible different hardware, right? And this makes them very attractive for especially car makers, where they can develop one single set of applications and then develop and deploy into different type of hardware. Into the head unit, we have developed a few services that are the Lambda functions that you see here in this picture. We are simulating the telemetry, so we are able to simulate the telemetry of a real car. We are simulating the user behavior. We are simulating the trip data, so GPS, like if the head unit is really navigating between a point A and B. And more importantly, we are simulating the battery data, which is the most important type of data for this program. The Greengrass Stream Manager, which is directly attached to the IoT cloud, provide a communication channel out of the box. So another beauty of Greengrass is that you don't have to lose your time in creating a MQTT communication channel or any other communication channel, because this comes out of the box. And the Stream Manager keeps all the communication in a safe manner. If we move to the next slide, we will see the other part of the story. So we said we need a head unit. We need a mobile phone that we have developed, and incidentally, into the mobile phone, we have also integrated Alexa, which is a virtual private assistant that can assist the drivers and the passengers in all the different interaction with the different charging point operators. And more importantly, we have developed a connected vehicle platform, of course, a small-scale connected vehicle platform, which is shown again into this slide. We have used a typical Amazon Web Service pattern for the connected vehicle platform. In the left-hand side of this slide, you can easily recognize the head unit that are attached to the IoT core. The IoT core has the responsibility for authenticating all the messages coming from the different head unit, and then to route those messages into the different services according to the type of messages that are received. In our case, we can, as you have seen in the previous slide, we can generate telemetry, and therefore you have a layer where we can review the diagnostic coming from the vehicle. We can generate the trip data, GPS position, and where the car has been driving, and therefore we can analyze, for instance, the user behavior. But more importantly, we can receive the data from the battery, as you remember, is one of the 4 applications that we have developed into the head unit. And this data will flow into the anomaly detection layer that you see on the top of this slide. This is the layer in the connected vehicle which is responsible for receiving the data, the battery data, storing locally for local processing. In the end, this is the connected vehicle platform which is owned by either a mobility service provider or a car maker. And then, which is the scope of our project, this data can flow to the EV mobility service platform, which is what we have developed. And with the mobility service platform, we can provide additional services to the car makers. And this is exactly what we want to show in the next slide. The electric vehicle mobility service platform is the core of this project that we have done together with the Amazon Web Service team. In the bottom part of this slide, you can again recognize the integration with the connected vehicle platform through an API gateway. So all the communication between the head unit and this platform is actually intermediated by the connected vehicle platform through the API gateway. Cognito has been used for the authentication. because in the end, the users that we are serving, the consumers, the final drivers, are the users of and are the customers of a mobility service provider. And therefore, with Cognito, we need to create temporary tokens that will be used to put in touch the mobility service customers with the charging point operators using this temporary token for the authentication. So this is one of the reasons why, one of the secrets why, in the end, the mobility service provider customers will use any possible charging point operators, because we can intermediate, the connectivity between the connected vehicle users and the charging point operators themselves. So this is one of the most important features that we are providing into this platform. On top of this, you can recognize, three major pillars, and the most important is actually the one on the right-hand side, the mobility service, is a collection of Lambda functions where we are managing the data coming from the battery. In fact, you see the battery level, but also all the transactions that the user can go through to book a charging session, sitting into the cars and looking into the navigation system. It will just tap in one of the charging stations which is available for him, and the reservation will be triggered automatically. And you will see later on a video that will show this functionality. We can manage all the transaction around the billing, so the user will see in advance which is the cost for the charging session, and will decide which is the most convenient one, based also on the type of subscription that is subscribed at the beginning. On the left-hand side, the EV roaming services is all about the management of the third parties. Here is where we can interact with the connected vehicle platform. So here is where there are the functionalities, for instance, for communicating with the green grass containers that are into the head unit, and to make sure that all the data from the charging point operators can flow and be displayed within the navigation system into the vehicle. And at the same time, of course, here we manage the integration with third parties eventually providing the roaming services, or any other content and service provider that can provide data that are useful for enrich the data and provide some value-added services and applications, as we will see sooner in the second part of this presentation. The central pillar is all about a series of DynamoDB tables, which is where we are storing the data. So this is actually the core of our program, is where we have developed the most important functionalities that we can provide today, which include the possibility, as I said, of providing roaming across different charging point operators, to book and reserve a charging station from the typical touch point that are the mobile application and the onboard infotainment service, to see in advance the billing and to pay, eventually using a mobile wallet. Because one of the third party that we have also integrated into this platform is a internet payment gateway that makes available a mobile wallet to make automatic payment across any possible charging point operators. Is this enough? No, possibly not. We want to add additional application, additional services based primarily on the fact that we can go into some in-depth analysis of the battery data. So we want to use the advanced analytics, and in some cases also artificial intelligence engines, to get the major value out of the data coming from the batteries and providing some additional services. How? Let's see in the next slide. So we know that the batteries will not last forever, unfortunately. And also, the degradation of the batteries will be progressive along the life cycle of the battery itself due to the multiple charges. And if the users will use the fast charge option, this degradation will be even faster. There are a few vital parameters that are associated to the batteries. One is the so-called SOH, state of health of the battery, that gives the real status of the battery after multiple charges. In other words, the real capacity of a battery will decrease over the life of the battery, and therefore, as a consequence, also the autonomy of the vehicles will decrease until, this level will reach a critical threshold, and below this threshold, the autonomy of the vehicle will be finally compromised, right? And therefore, predicting when this will happen will give car makers, but also mobility service provider, the possibility of creating new applications and new services that are bound to the fact that we know in advance this data from the batteries. So let's see what we want to do in the end. Well, our ambition is to use the mobility service platform as a kind of processing platform of a broad variety of data that you see on the left-hand side of this slide. We will know, of course, the state of charge of the battery. We will estimate the state of health that I just mentioned. We want to consider the driving style of the user itself. We want to know where the user is headed to, the routing, the car status, how the vehicle has been driven, all the possible information coming from the connected vehicle or from other parties that can, add data like the weather forecast or the weather status that are necessary, for enriching the original data. We want to process this data, and we want to provide some additional information based on, for instance, the car configuration. In fact, one of the possibilities, especially for the electric vehicles, is that during the journey, the condition of the vehicle will change due to the fact that the battery itself, will slowly discharge, and eventually, if the weather conditions are quite, let's say, bad, the battery will discharge even faster. And therefore, it will be possible, eventually, dynamically changing the car configuration, the car settings, to make sure that the autonomy of the vehicle will be always maximized, especially if along the route from A to B, there will be no available charging stations for that specific user. And therefore, the autonomy should really be maximized as much as possible. So we have already thought about a new set of possible use cases. And in this slide, we have just put a couple of them. The first one on the left-hand side is more, let's say, addressed to the passengers and light commercial vehicles owned by private people. And that has to do with the fact that we can optimize the route, as I said earlier. I mean, the day that when users decide to go from A to B, we will know in advance the state of charge of the battery, the state of health. We will get information around, the weather forecast, the driving style. We know the status of the car, and therefore we can decide that the trip to go from A to B, the route to go from A to B, should be actually different from the shortest route. It should be the route where the autonomy is maximized, or the route where we will be sure that the user will find a given number of charging points and charging stations, where the battery can be recharged. On the right-hand side, we have put a typical use case that is more suitable for shared mobility scenarios. Here, a mobility provider, a shared mobility provider, may want to reward those users that are, let's say, battery saving, so that they will adopt a driving style that will save the battery life, and they can, be rewarded with additional tokens or money that they can spend, in recharges or in a restaurant or any other circuit. So it's just a matter of, rewarding those customers, those drivers that are really conscious of the fact that their driving style will have an impact on the battery. How can we do this, right, with the platform that you have seen in the previous slide? Well, there will be, of course, some modifications to be done, and this is and will be exactly the work that we want to do in the next few months. So there will be modifications both in the mobility service platform, which is on the right-hand side of the slide, and on the edge, so on the onboard unit. Let's start with the backend, with the mobility service platform. We will develop a new layer that we have called the battery services, and you see, the details of these battery services in the bottom part of the slide. Well, first of all, there will be a battery model lifecycle where we want to gather a huge amount of data coming from batteries, from real batteries. And to do that, we will be cooperating with battery manufacturers that have this data. So we will use real data coming from real trucks and buses and vehicles and cars, for doing what? Basically for training a model using a machine learning mechanism, which is based on SageMaker in this case. And we will train this model until we will get a satisfactory model able to assess some vital parameters of the batteries. The state of health of the batteries is just one, but we have in mind a few others that will be necessary to be estimated. Once this model will be mature enough and will get the necessary level of confidence, this will be moved into the battery scoring service, which is the upper layer, which is where the model goes actually online, right? At this point, these models will receive the data real time or near real time from the cars, from the vehicles, and will generate all the necessary data that can be used eventually by a mobility service provider for sending commands to the car and change dynamically the settings, as we have seen, in one of the use cases previously mentioned. Or this data can be also used, for triggering some after-sales activities, like, if we really realize that the battery is reaching the end of life or is reaching the critical threshold below which, the autonomy of the car is really compromised. Well, the car maker in this case has a powerful means, to advertise, to advise the customer and, propose some battery changes. There will be some changes necessary also on the edge, of course, on the edge unit, because we need to develop the necessary services to gather the data from the vehicles, from the batteries, to segment, to transform, to pre-process, and to send this data into the backend. And at the same time, we want to deploy into the edge itself, so into Greengrass, in other words, a small scale of the model that we have trained into the backend, because there will be certainly some actions that needs to be taken in real time by the car itself without relying upon the fact that there is a communication with the backend. For, let's say, latencies or, for the lack of communication is sometimes necessary for safety reasons, that the car can take some decision real time. So this will be the scope, for the next work. And in the end, what we want to do is having our mobility service platform with all the necessary capabilities and features to build value-added services, real value-added services that will make the navigation for electric vehicle much easier and smoother. So at this point, I have a video that I want to share with you that shows, what is the journey of a typical customer using this platform. So what you will see here in this video is the real usage of the mobile handset application that we have developed, where Alexa has also been integrated. You will see the head unit in action, where Greengrass has been deployed, and you will see some of the applications, some of the services that the platform in the backend is providing into the head unit and into the mobile handset, with a specific focus on the roaming, so on the fact that the user may decide to use any possible charging point operators during the trip. So let me now get started with the video. So initially, the user, of course, needs to register. Is the customer of a mobility service provider, of course, and therefore using the application, the mobile application, or using the application into the onboard system, it will activate the service and will select also which is the best charging plan that you want to subscribe with. So there is also the possibility to select different charging plans. Now the user has been activated and they can plan a route. So this is the unit where Greengrass is running, by the way. And you see that we are now getting to the point where we need to recharge our batteries. And here you see the possibility for this user to select one of the many possible charging point operators, all the charging point operators that his mobility service providers have contract with. Now this is being selected, the most convenient, the timing, and the reservation is now successful. So everything, using the onboard system or the mobile application. There is also the possibility to use the mobile application that has exactly the same type of services and features. Now the user is driving to the charge station, is checking in, and again, the check-in mechanism should be just unique, just one single check-in mechanism. In this case, with the companion application and a QR code, which is taken to be authenticated. And you see here there is the authentication between the charging point operators networks and the mobility service provider platform through our mobility service platform. So with one single account, the user is able to check in any possible charging point operators without remembering many passwords and different account systems. So this drives me finally to the conclusions. So, well, it is clear that the electric vehicle mobility market will grow if the infrastructure will grow. I mean, there is still a lack of public infrastructure that is somehow limiting the growth, of the electric vehicle mobility, but this will happen, right? So the fact that there will be new charging point operators, that there is this, let's say, a convergence between the mobility industry and the utilities and the energy industry will for sure, facilitate the growth of a suitable infrastructure for the electric vehicle mobility. The roaming across the charging stations is an important feature. All the car makers that are also mobility service provider are looking after these features, because it's one of the features that makes the life of the electric vehicle user really much easier. And I hope that with this presentation I provided you a view about the platform that we have created, all based on the Amazon Web Service technology. And one important piece, in our opinion, is that this is not really, as I said, at the beginning of this conversation, just a bunch of different services and applications ready to be integrated in any connected vehicle platform, but could be considered as a kind of self-standing platform, easily connected to any possible connected vehicle platform or mobility service provider platform, to provide a huge variety of different services that will grow, as much as possible. And you have seen also, our plan to use advanced analytics and artificial intelligence moving forward to create really compelling services moving ahead. And this is all for now. Thank you for your attention.